Gabriel with you again, and I'm a data analyst at Data Playground. Our topic today will be looking at data types, data sources, and data quality. So we have a very simple scenario here. It's a Thursday morning, and of course, you've been at TradeFlow for say about 2 weeks now, and you're starting to find your feet. So your boss, Amina, shares a file to your Google Drive. She says this is our master customer list. Marketing needs a breakdown of our top customers by country and age groups. Can you have something ready by the end of the day? So you open that data set and you have about 2,000 rows looking at you. Well, it looks manageable. You have customer ID column, you have the name column, you have emails, country, age, registration date, total spend. Perfect, and that's exactly what you need. But then you look closer at the data set, and then you find out that the age column has you have 27, and then you have 32, but this time 27 is written as number and then 32 is written in words, and then you have not available NA, you have zero also. Yeah, of course the person cannot be age zero. You also have old. Now these are of course data quality issues, and then you look at the quality, the country column, and you find out that some countries are spelled out probably, for example Nigeria, and then you have a place where it's written, just written as NG, and all these are actually data quality issues. So you stare at your screen for a long moment. You can't calculate the average age when some ages are written in words. There's no way you can group by country when the same country is spelled in four different ways. You can't sum total spend, when some values aren't numbers at all. So there is data looking at you, the data exists, but right now in this state, it's more or less, useless. So this is the moment every analyst faces sooner or later, and because real world data most times it's often messy, it might be complete, but you'll be able to spot a few data quality issues. And so how you handle it depends entirely on how well you understand the data itself. So we actually have different kinds of data. So not all data is the same, and how you analyze it depends completely on what type it is. And using the wrong approach for the wrong type of data is one of the common beginner mistakes that you see. It produces results that sometimes may look right but are actually meaningless. For example, if you think about, let's say, supermarket receipts, you have item, you have name, you have quantity, price, dates of purchase. Now you can add up the prices on that list. You can calculate the average price per item. You can find the most expensive thing you bought, because price is a number that represents a measurable quantity. But you cannot add up the item names. For example, you can't say bread plus rice plus tomatoes. That's not a meaningful calculation at all. So you can count how many different items you bought, but adding the names produce nonsense. So that means that the type of data you have determines what type of operation that you can perform on it. And some kinds of data, we have what we call the quantitative data. Quantitative data simply refers to numeric data. On quantitative data, you can perform mathematical operations on them. For example, you can easily calculate the sum, you can easily calculate the average, you can compare values together, you can find the maximum, you can find the minimum. Then another type of data you have is the qualitative data. Qualitative data is non-numeric. You can only count, and you can categorize these kinds of data. For example, item name can't be added together. That's because item name is an example of a qualitative data. So you also have the continuous data, you have the discrete data. For the continuous data can take any value within a particular range, including decimals. You can have distance, you can have time, you can have revenue. For example, a delivery distance of, let's say, 12.7 kilometers, simply that's a continuous type of data. But discrete data, on the other hand, can only take specific values, and most times they are usually whole numbers. For example, you can only have maybe something like 5 or 6. If you say 5.7, 5.7 is a continuous data. That's not a discrete a type of data. Then you also have another type of data, which is the time-based data. The time-based data is useful because it helps in unlocking unlocking trends. You can, for example, there's no way you can ask if performance is improving without time. So for example, data like order days, delivery dates, registration dates, almost every event for example your company TradeFlow has a timestamp, and time-based data, like I said, it just helps you to unlock trends. you know One thing to watch for: dates in real data sets, they are frequently messy. You come across this as we go on with this particular course. You find out that there are cases where you might have dates written as, for example, you might have them as maybe 14th July 2026, and in that case you might have it as maybe 14 hyphen oh 07 hyphen 2026. In that case you might even have it as 2026 hyphen oh 07 hyphen 14. So it probably come in different formats in different cases. So um at work, for example, when the analytics team gets the customer file, an experienced analyst would not just scroll through it, right? So like an experienced analyst will want to go through the data column by column and mentally assign a data type before doing anything else, because you want to know, okay, in this particular column, what data type is it supposed to carry? For example, we know that the name column is supposed to carry qualitative data, and that will determine the type of operation that you can perform on it. For example, if you are looking at the price column is supposed to contain quantitative data. That will determine the type of operations that you can also perform on it. So these are things that an experienced analyst will try to look at. You try to look at each column, and when you understand what each column represents, you can determine what data type should be there and what operations you can perform on it. So what you are going to do as your first exercise, you can find a random data sets online. Or in our project section, in the last project I did, if you check our project playlist there, I attached the link to my GitHub. You can check my GitHub out, and you possibly see a few data sets that you can make use of, and then you can just open it and see what you can make out of it. Or if not, you have later in this video, we get to a point where we have a very small data set, different columns. You can take a brief look at it, and then you should be able to identify, is this column quantitative or qualitative? If a column is quantitative, are the values there continuous or discrete? If a column is qualitative, is it nominal? Is it ordinal? Does anything look like one type but is actually another? For example, like customer ID. So now we have what we call data sources. When we talk about now no, okay, now we understand what data types are already. So when you talk about data sources, you are trying to look at where data actually comes from, because the source tells you a lot about how much you can trust that data. You can think of data sources like witnesses, like at a scene. For example, someone who was physically present at a scene is more reliable than someone who heard about an event secondhand. The further information travels from its origin, the more likely it has been changed, misunderstood, or distorted. So data just works that same way, and that's why we have three sources of data. We have the first party data, we have the second party data, and then we have the third party data. For the first party data, this is data that you collected yourself. Data your organization collected directly from its own operations or customers. This data of data is most reliable because you know exactly how and when it was collected. For example, at TradeFlow, every order, every delivery, every customer account, every payment, TradeFlow owns it. TradeFlow generated it, and TradeFlow can easily trace any value back to its source. Then now the second source of data you have is what we call the second party data. Second party data is someone else's first party data. For example, a partner's first party data, right? You can call it like a first party data from another organization, which can be accessed through partnership. It's still relatively reliable, but you have less control over how it was gathered. For example, if you have a courier partner, a partner that works hand in hand with your logistics firm, they could actually share their delivery performance data. Now, that to them, that data that they are sharing is first party data, but to you it's second party data. So for example, in the case of TradeFlow, you find out that TradeFlow did not collect such data by themselves, but it came directly from the source too. So the key thing here is just checking how the other party defines what they are measuring. For example, their on-time delivery might mean something different from yours. So now that's where the issue of communication comes in. You need to understand what the data means to them might not be exactly what it means to you. And then the third source of data is what we call the third party data. Third party data is collected by someone else for everyone. It can be collected by an organization with no direct relationship to the people or even the events you are looking at. For example, you have market research firms, government agencies, aggregators. All these, if you get data from all these, you can actually more or less call it like let's say third party data, right? So this data is actually still useful. It's useful for context, but it comes with the most uncertainty. You often don't know exactly how it was collected or whether the definitions align with yours. You can use it for direction anyway, but you can't use it for building critical decisions alone. Then now we also have what we call internal data, and then we have external data. Internal data is data that is generated inside your organization. You have high control, and then there's usually high reliability. But external data, on the other hand, comes from outside, comes from partners, public sources, competitors. It adds context though, but it could come with questions about reliability and recency. So the truth be told is that these two are important, and in most cases the best analysis tries to combine the both of them, because internal data can tell you what's happening inside the organization, and external data can tell you what that means in the wider world. For example, if you go back to the work scenario, the marketing might want to know if trade flows customer acquisition cost is competitive. And so the analyst will then pull TradeFlow's own cost data from the internal finance records, which is first party and then is highly reliable also. Then you can also pull an industry benchmarking report from a research firm. That's third party data. And then before combining the two, the analyst checks, does the research firm define customer acquisition cost the same way, same components, and in the same year too they are trying to collect your own internal data. So it turns out the research firm might even include offline marketing costs, while TradeFlow's internal figure only might just include only digital spending. So without catching that particular means of collecting data, you find out that you find out that the comparison would have been meaningless actually, and it might even be potentially misleading to leadership. So trying to check all this will actually help you to save time and also reduce the chances of making very serious mistakes in your data analysis. So let's proceed to understanding what data quality is all about. On data quality, this is actually a very, very practical part. This is a very, very important aspect. And truth be told is that most real world data, like I've said it over and over, it's often not ready to use. You would always have a few issues here. It's only in, let's say, textbook kind of data. Textbook is By textbook I mean an ideal case where you might have a perfect data that has already been cleaned out. All you need to do is just analyze. But in the real world case, you often have data quality issues. So I'm not saying this to discourage you, but I'm saying it to prepare your mind so that instead of opening a file and just assuming it's ready, you should open a file, you should open a data set, and you should ask what's wrong with this and what do I need to fix before I can trust this data. Because like it or not, you could do good analysis, but because your data has a few quality issues, you still come out with the wrong decisions. So that shift from assuming the data is perfect to questioning the data is what separates analysts who produce reliable work from analysts who occasionally produce confidently wrong conclusions. So data quality has five dimensions. The first dimension is completeness. These points where you ask, is everything there? Are there any aspect that is actually missing? Now, truth is that in when you are going through a data set that has just come fresh to you, this is one of the most visible problems that you can spot, because you would have blank cells, you could have nulls, you could have not available NA, or rows that don't exist when they should, right? So in a case whereby you are having let's say a table that is supposed to contain numerical data, and you have some of the cells missing, what do you do in that particular case? So that's the first data, that's the first dimension of data quality: completeness. The second dimension is accuracy. Now, does this represent reality? Now, the accuracy quality is a little trickier than completeness, because inaccurate data will not always announce itself. That's the truth. You will not always have inaccurate data announce itself. For example, a missing value in a data set would leave a visible gap, right? But an inaccurate value will still fill the gap, but this time it will fill it with something wrong. And wrong values that look right are far more dangerous than obvious blank cells that you have in your data sets. For example, negative stock quantities in TradeFlow's products table. You really can't have negative physical stock. Is it even possible that you have minus 5 pen in your warehouse? So anyway, that's an accuracy issue. Now, the third dimension is consistency. In the case of consistency, is this data recorded the same way every time? For example, in the column that is supposed to contain country, if you have Nigeria, let's say the first letter is capitalized, you might see another cell where all the letters are used as lowercase, and then you might see another cell where all the letters are written in uppercase. You might even see another column where you just abbreviated it to NG, for example, instead of writing the full Nigeria. So that's an issue of consistency. So in this case, you have to ask yourself, is everything in this particular column recorded the same way? Then another issue is validity. Do the values actually make sense? For example, if you have an age column where you are having 0, is it possible for someone to be 0 years old? Like, I mean, an adult that is purchasing, for example, that is purchasing goods from an e-commerce store like TradeFlow. Is it possible that the person will be 0 years old? So that's the issue of validity. The values you would not always make sense. For example, someone cannot be aged 200, someone cannot be aged 15 era. I mean, so you have to validate your data there. Then the next one is timeliness. How current is that data? Now, truth be told is that old data, this doesn't mean that old data is automatically useless. No, old data is not automatically useless. In fact, it's valuable for trends and forecasting. But if you are trying to answer questions about right now, and you are using a 6 months old data, that would definitely lead you astray. For example, if TradeFlow's operations team makes daily delivery decisions on data with a, let's say, a 3-day lag, they might be reacting to a problem that has already been resolved because they are making use of old data there. All right, so let's look at the data quality audit now. Before any analysis, before calculating a single thing, always try to do a quick data quality audit. 15 to 20 minutes is usually enough for a first pass, but yeah, it should always happen, right? For example, the first step in trying to audit your data quality is to ask, how many rows and columns do you have? Asking how many rows and columns your data set has would help to give you a scale and a baseline. For example, um if an expected data set, let's say you expected the data set that has about 10,000 orders, and when data sets came to you, you had a data set that only had about 9,847 orders. You should ask yourself, what happens to the other 153? So ask yourself that question, how many rows and columns do you have in that data set? The second is to scan each column. Now, you are scanning each column because you want to assign a data type to each of them. Like I said earlier, knowing the data types for each column will help you know what kind of operations you are supposed to perform on that for each column that you are looking at. The next is to check for missing values. Yeah. Oh, it's very important that you check for missing values. How many blank cells do you have per column? Do you have clusters somewhere? Like all missing dates, do they belong to one courier? So then the next one is to look for consistency problem. Are all dates recorded the same way, right? These are issues that you should look out for. Specifically, you should be scanning your text columns. For example, your country column. Country column is actually supposed to be a text column. You should scan there. How are the casing of the words? Are they uppercase, lowercase, first letter capitalized and the rest small letter? Do they use short forms and all? Then next is to try to validate your data. Check for validity problems. For example, in the age column, you cannot be having zero as someone's age, so you should check for that. And then lastly, you should check the date range in your data sets. So this is a problem here. You are going to try to spot every problem in this table. In this table, you have about let's say 8 distinct issues here, and so you try to see how many you can spot. You can pause this video right now and see how many problems you can spot with this data set. That should tell you. But I'll give you a hint. You can look at the country column. There's definitely something to spot there. If you check 10 ID 1005, you have it is duplicated, right? In the country column, you have one of the countries there is written as all small letter. You have another country that is written as just in short form, like for example, let me say NG. I've given you an expo there. Then the age column, you also have something strange there. You have three strange things there. Then also in the registration date, you also have an issue there. In the spend, you also have an issue there. So that's your task anyway for you to do. Now, why do data quality problems happen? Now, understanding why data is messy helps you anticipate problems before they even surprise you. Quality problems, for example, they would not usually happen because people are careless. Most times they happen because data passes, through many hands, systems, and processes even before it reaches you. So each handoff is a chance for something to go wrong with that data set. So data quality problems could occur due to human entry errors. For example, someone decides to type 32 in words instead of 32 as number. That's a human entry error. Dates that maybe that probably were stored one way gets imported as something else. You can there are different issues there are different sources of data quality problems. And that issue could be from system migrations. By system migration, you mean you are taking your data from this point or maybe from one platform to another. For example, you are importing your data set from one sheet to another, and in these two sheets dates were formatted in different ways. Of course, definitely you are going to have issues there. Then another is multiple sources combined. Then another is missing data by design. Yeah, sometimes you'd have issues with data that is missing in your system. And then the last one is from historical accumulation. Data acquired from historical records could actually bring a lot of problems. So like you have a data isn't the data isn't broken to spite it. It's just messy because it's created by human systems, and truth be told is that human systems are imperfect. So the next task that you have here is to write a data quality report. um your boss, Amina, shared TradeFlow's full customer data set, and she has asked for quality reports before any analysis can begin. For example, you should ask yourself, is this data ready to use? If not, what needs fixing first? Right? So what you are going to do is to look at the full data set, the rows, columns, time. This is actually more of a hypothetical data set. There's no wrong answer because you don't have a data set staring at you right now. But just make a few assumptions, right? You can overview, okay, how many rows and columns are in this data set, because you are going to give her a report of it. How many rows and columns will tell you, okay, how many others are actually in this data set. Then you should maybe be able to bring out a list of data types that will be in that data. You remember, you're looking at TradeFlow, which is an e-commerce company. So what data types are likely to be there? Then what quality issues are likely to occur? What would you recommend? How would you go about or I know, yeah, you've not been exposed to any tool at all, but how would you go about fixing some of these quality issues, right? And then the last thing is, this data ready, and what's most critical to fix. Like I said, is a hypothetical data. You are free to choose anything, any particular data set that maybe you come across, or you can just create a hypothetical data for an e-commerce platform. So like I always do, I'm going to drop my mail in the description of this video, so you can send me your feedbacks, and then I'll go over it and tell you what I think about your work. So to summarize, data is not neutral. Data has a type, data has a source and a quality level, and each affect what you can do with it and how much you can trust it. Quantitative data can be measured and calculated. Qualitative data can be counted and categorized. Time-based data unlocks trend. First party data is your most reliable foundation. Third party data needs careful verification. And real world data, like I said, is often messy in ways that are not obvious still. You look closely at that data set. So in our next video, we are going to bring all we've done together, right? And we are going to look at the analytics life cycle. We'll walk through the full journey of a real analysis from the moment a question is asked to the moment a decision is made, and we'll see how problem framing and data evaluation connects to analysis and communication. And after that, we'll pick up a tool for the very first time. So thanks for going through this video, and I do hope that you like this video, you share this video, and you subscribe to our channel. Thank you.